They've locked us all in, almost. And it's me between you and lunch. All right, good morning, everyone. Welcome to Counting Records in ABL. I'm not going to say 1, 2, 3, 4, because I'm going to get a song stuck in my head, and I'm not going to sing, because I don't want to do that, and you don't want that. Maybe Vim can sing later. Yeah, so we're going to talk about counting records in the ABL. Another real troublemaker has arrived at the back of the room, so now I've got to be careful what I say. My name's Peter Judge. I work for Consultingwerk recently. I previously had Progress. I've been working in ABL for 4GL for some time, 25 years, 26 years, something like that, long enough. Mainly, I like kind of libraries. I've done a lot of work in frameworks and toolkits and the like, but also done a bunch of work on PAS recently, yeah, mainly with Progress, with migrations and stuff like that. PAS is fun. HTTP stuff is fun. I quite like that. So as I said, I work at Consultingwerk. We're a consulting organization based mainly in, or headquartered in Germany, but with offices in the US and other parts of the world. At ABL shop, we do consulting. We have our framework, the Smart Component Library. I'll get the spiel right one day. This is only my second time doing it. So, yeah, and a bunch of other services. Progress, mainly progress-related technologies. Mainly progress. All right, so why do we want to count? Why do we care about counting records or anything? Well, I think primarily the primary audience is for that not users all use, the UI, right? UI affordances. You've all seen, not all of us can be like Google. We can say roughly one of 27 billion pages, right? Tend to be in business applications. You want to know how many pages you've got, that sort of stuff. It's very useful for that. It's also maybe useful to know for query optimization. Sometimes you have a for each with 2 tables, and it might be faster to read the one with the fewer records so that you can get, you know, you can filter down more. There's reasons for that. Allegedly, DBAs care about the records, although some of them just say they care about the total size rather than the number of records. But I'm sure they do care about how many records there are. What do we want to count? Sometimes we want to count all the tables, all the records in a table. But if we're working with UIs, we may also want to care for a subset, right? How many orders are there for a particular customer, right? So you may want to be able to say, okay, well, there's 15,000 of them. We want to break it down into chunks or something like that. So how do we count in ABL or in 4GL? We're going to look at a couple of these. Not so much the bottom one for counting, although there's information available via the query info handle. But for eaches, pre-selects, counts, SQL counts, accum and accumulate. Who's used accumulate in their code? Nobody. You can admit it, it's okay. It's there. It hurt my head once upon a time. Back in the bad old days of writing reports. My first job, you know, the first thing the junior programmer gets to do is you get to write the report on a Friday, you know. Business wants to know how much of this is and what the aggregates and averages and stuff. Yeah. And then we'll look at the new N12.4, I think it is, aggregate statement. So, who doesn't know what a for each is? Trick question. For each, right? Everybody knows a for each. It's the easiest. It's just for each. 1 plus 1 plus 1 plus 1 plus 1, right? It's been in the language since the beginning, Gus, right? It was always there? Yeah. Yes. So I can take the quotes out next time. It's all language. Everybody knows it. Everybody loves it. You can do a lot with it, right? Supports table joins, filtering. When I say filtering, I mean where clauses, basically. I'll use the phrase a couple of times. It can be impacted by the network settings. So when we're using a shared memory versus a network database connection, it's impacted that way because of the data that has to travel across the wire. It supports the fields phrase, or the fields clause, fields modifier on the thing, which lets you limit how much data comes back. And then there's a table scan option, which basically says, I'm just going to read the record blocks rather than the record and the index, which is normal. There's some qualifiers on table scans. You have to have a type 2 storage area in order for that to work. So that's the first one, right? Everybody knows and loves that. Secondly, we have this combo of accumulate and accum. So there's accumulate statement. and we can say we want to accumulate cusnums, and we want to do a count, and then afterwards we can get the value of that count out, right? So an accumulate, an accum. Again, it's within a for each, so we can do joins, we can do filtering, right? We can limit the amount of data, which is pretty nifty. Also, I don't think very often used because it's gnarly and complicated and hard to get to work, I think, but it exists. Third option uses SQL from the ABL, right? Select count star into a variable, right? Been in the language since V5, or 9.1b for the SQL 92 engine, and it looks like that. Select count star into a variable from customer, and again, joins and filtering, right? Customer, comma, order, whatever the syntax is. I can tell you in ABL, but not in SQL. But we can do filtering and narrowing down of those data, of those records, right? So it's not just the whole table. On to my favorite, or typically favorite, pre-select each, a query. So we define a query. We open the query with the pre-select phrase, or the pre-select keyword rather than the for. And what that does is it figures out what the result set is and tells us how big the result set is. So we just have to open the query. We don't have to iterate over each of the records to go and count them. We just say, tell me all of them, right? They're pretty quick and pretty easy. Has the same issues, and again, the accumulate and the for each and the pre-select has the same issues, the same questions with network operations, right? With network databases, as I'm sure everybody knows, it's much faster doing shared memory. Fields helps with that. I don't believe the table scan is supported with a query. Yeah, so you see, look, result set is initialized. And this, for the longest time, until I started putting this deck together, or this talk together, this was my favorite way of doing it, just because it's fairly quick, fairly easy. You can do the dynamic programming model as well, right? Dynamic queries work exactly the same way. Pretty nice. In OpenEdge 12.4, a new set of functions came in, including the aggregate. And so there's an aggregate keyword. The syntax is up top there, and we can say we want to count by a field. Again, it's very similar to the accumulate. We have to say I want to count by a field. It's an indexed field for customer, for a table. It's a single table only, but we can filter. So we can have a where clause on this. All right. It's automatically no lock, which is nice, so we don't have to think about it, although when I see that, I want to put no lock on it because that's just my habit from 20 years of writing for eaches. The doc very handily says, it may be faster than the accumulate statement. We'll have a C on that. So those are the 4 or 5 different kinds. Did I forget anything important of the counts? I think those were all of the ones that people use. Anything anybody else uses in the room that they use to count records from the ABL? You have them?
I do a count on an empty string.
Can you just...
Count on an empty string, not on a field.
You do a count on an empty string, not on a field?
Yeah, for each.
Ah, okay. Okay. So we're going to have a look at how these things stack up, right? Obviously, some of these, I should just note as well, so the aggregate will work on database table, the others will, and the SQL will work on database tables, the others will work on temp tables as well, right? So if you've got a business entity type approach where you've got your business lot, you've extracted database records into a pro data set or into some temp tables, you won't be able to use the aggregate on that, or I don't believe the SQL stuff either on those tables, right? You'll have to use for eaches and pre-selects. That's usually not always so bad because the whole point of, or a point of putting it into temp tables is that you reduce the amount of data that you put in there. But you may want to know how much more data there is to come, so you may still want to look at the database table in your application. All right, so we're going to do a couple of tests on this. We will start just some background. We're using a modified Sports 2000 database. It's put some of the, it's had the schema cleaned up. It uses type 2 storage areas for some of the tables. The customer record, the customer table, which is what we'll be working on, is 200-ish thousand, 210,000, I think, records. Haven't done any tuning on the database server, except for served it up over the network. So we want to test on network connections. Simple.ps, we'll see the examples. We're going to do a couple of queries on the .ps, on the customer table, and a couple of configurations. And the clients are connected to that database using -s, right? All on the same machine, but still over the network, right? And if we have time, maybe we can run the same queries without the network connection and see the difference that makes. We'll also go look at a couple of VSTs, the index and the table stats, just to see how many index records are read, how many indexes are read, how many record blocks are read as well. And we just use ProTop for that because you can do all of this in ABL, but it's a lot of for eaches, and it's, I say prettier in that version, but it's visible. So hopefully you can read that from the back. You should be able to. Okay, so let's take that off and find my... All right, so hopefully everybody can read this. So we'll start with for eaches. And so kind of the premise is more or less the same in all of them. I do like my pointy thing because it's pointed. Right, we have a counter variable. We've reset it to 0 every time, a mistake I make all the time. And a timer using millisecond times, right? That's what now gives us a millisecond timestamp. And we just count, and we dump all of our code into a flat file. So we're first just going to do a whole table scan. We're going to secondly do a for each, same for each, but now with the table scan option. See if that makes a difference. The for each with an empty fields phrase. So for this particular query, right, we don't care about any of the fields. We just want to know how many records there are. We don't care about we don't care about custom or anything. We just want to know how many records there are. Next query is we're going to do an indexed subset. So where the custom, that's about half by number of the customers. It's not half by quantity. There's about, I think there were 12,000-ish records that this returns. One of these is 12, one is 18,000. So that's the primary unique index, so we'll see how long that takes. Then we'll search on an unindexed field. Credit limit in this database is not indexed at all. So we would expect that to be maybe not quite so fast to get our data back. Yep, and that's the first one. So we'll do the same, roughly the same methodology. Obviously, like the SQL stuff, we can't do fields lists, and we'll see how that goes. So we will run our first one, and that chugs along. And what are we looking for each text? It's busy trundling along. Oh, I was going to put it at the bottom, but that's all right. Come on, yoo-hoo. There we go. Doesn't really matter where they go. All right, so that's roughly our results there, right? 201,000, I said 210, 200,000 records in 1.5 seconds. Fairly consistent, right? Maybe we gain a little bit on the fields list. Indexing is awesome, right? I mean, I know we're getting significantly, we're 5% of the records, but it's significantly faster. Unindexed is 10% of the records and significantly more than 10% of the time. So that's our first query. Our second one, where should we go next? Let's go to accumulate. Why not? So accumulate, again, our syntax, where was it up top here? For each customer, we accumulate, and then we count. And in fact, what I can do, let me just rerun that, and I will just go and clean up my, why is ProTop being, of course it's going to do this to me now, quit. Let's try that again. Bunk, start, put in programmer mode, which apparently we want, press that option. All right, so we can see over, where'd it go? No, that one. We can see, we'll see the table reads over here, we'll read the index reads, and then this is some network traffic at the bottom. And so we'll run our for each again. And wait till that goes and works its way through. Okay. Sample again. And so we can see here we've read 1 million. So remember we had 5 queries there, right? We have 5 queries there. We've done 1 million table reads, right? So we read 3 of them, 4 of them, 3 of them, all 200,000 plus another, you know, what is that, 30,000, 40,000 results returned, 30,000 returned. So we've done 1 million record reads on the customer. We're all working on the custom index because that's the primary index. So the for eaches that don't have filtering will use that same index. And our unindexed query obviously doesn't use an index. So we can see there's a fair amount of record reads. There's 614,000 index reads as well. So I'm guessing that'll be the 201 times 3 plus the whatever that is, plus the 11,000, right? So those are all the index reads. Fair chunk. We'll reset that again. And go take a look at our second sample. So our second one we can look at is, what did I say, accumulate. We'll look at the accumulate statement, which is very similar, right? From the for eaching point of view, again, for each no lock, for each table scan with the accumulate and count, customer fields, accumulate and count, indexed, unindexed, etc. to that. So we'll run as our procedure. Here we will open accumulate, if I can spell, accumulate.txt. And we've got our 5 in there. And so we can kind of see the times are significantly larger, right? They're quite a bit more. We reset our table reads. Also, quite a bit more, right? We were at 1 million, we've read another 200,000 records. But we've got an extra read in here, right? So we've got a non-indexed field, and the accumulate actually read, instead of, that's interesting. Oh, because I've added a 6th one. Interesting. I didn't have my non-indexed field in there. No, there's my non-indexed field. What did I change there? Nothing. All right. So we have the extra one. Let's take that out of the results. And we have the same 5 output. So far, pretty similar, right? It's got heavy reads on the customer table, on the records, and on the indexes as well, whenever we've got our indexed reads. Next, we can look at some SQL statements to do the similar counts. So again, these are fewer. Select count from there into the customer table. So that's the whole table. The same to where clauses, 1 indexed, 1 unindexed. We'll run that. And did I clear my numbers here? So just reset that and run as application. Save those. And here we're going to say SQL select count.txt. And so we can see, I'm going to stack these like that, right? So against our kind of standard, let's go our standard for each, a little bit faster. The index subset is in the same ballpark. And our reads now are significantly, well, our index reads and our record reads are pretty much the same. Did we do the unindexed one? We did the unindexed one as well, and we still have the same number of index reads and things. So the index reads are the same. Onto my favorite, or my previous favorite, well, my favorite, I'll give myself away, is our pre-select. So let's do the pre-select, and that's running. And again, this is pretty much the same as the same queries, pre-select.txt, the same queries that we had before. So the for each, the pre-select for each with fields list. So the fields you define on the query statement, not on the open query for queries. With the for each, we set it on the for each, and on the query, we set it on the defined query. And that runs. And again, faster than the for each, but not significantly so. Reset that. Remember my order of resets. Reset that. And let's run that again. One, 2, 3, 4. 1, 2, 3, 4, right? Pre-select is the last one, is unindexed. And we can go look at our indexed and our table reads. And here again, pretty much the same number of reads on both, significantly lower. Right. So the timings are more or less, we're still getting a bit better with pre-select. It's 1.1 seconds for the 200,000 as to 1.4 seconds for the 200,000. I wouldn't say it's margin for error. I mean, if we look at the indexed ones, we've gone from 76 to 69, so it's the run is a little bit faster. And each of these runs is a separate avm.p, so there's some form of caching and on the same surf database. The dash big B on the database is whatever the default is. Okay, so that is those ones. And then finally, the new aggregate statement. So as I mentioned, this is in 12.4 released. We can do things like this. Aggregate count is custom of the field as well. So syntactically, you have to put a field name in there. I don't think it makes a difference whether you say count of custom or count of address or count of anything. It's just doing a count on the table. Same 3 queries, index subset, unindexed subset, and all of them. There's no fields option or anything like that on the aggregate. Clear that. So do we expect this to be faster? Do we expect it to be the same? Hope so. All right. So we can run that, and we'll run that, and we'll go get aggregate.txt. All right. So if we expect it to be faster, how much faster do we expect it to be? The troublemakers in the front there, just breaking the furniture, Any guesses on how much faster it will be? We're at about, let's say we're 1400 milliseconds from a for each. Where do we think this is going to be? Anyway, I was quite 300. You got a guesstimate here? That's quite fast. It's awesome. Really, it is. It's like I expected it to be faster. I did not expect that the first time I saw it. And again, significantly lower counts on the. So we read the table once, right, for one of the queries because we didn't have an index for it. So we had to go read the table for that. I suspect that's why we read those 200,000 records was for our unindexed query, right? Even though we only returned 18,000, but all of that stuff happened on the index. And the other thing that was done is those queries are resolved on the server. So again, if we look at we can go back, but if we look at the network traffic down the bottom here, there's, again, this is a little beyond me, but really the amount of data that's sent across the wire is significantly less. So again, kind of 12 had that theme of server-side processing for a lot of stuff, for a lot of database stuff. And so that becomes significantly faster because of that. Obviously, this is all on one machine, but yeah. So that was that. I think that was that. Yeah, so that turned out to be much chugga-lugga. I'm sorry. So yeah, so as we can see, the aggregate is very fast. Again, it's very fast on database tables, right? When I wrote these slides, the for each was next best. As we saw today, the pre-select was faster than the for each. And I think your mileage will vary a little bit on exactly what that query is. Indexes matter, right? When we saw the index queries, significantly faster, again, because the amount of data that gets read from the database, from the records, is a lot less, in the indexing. And so the database connection, we can take a look at that as well, also matters. If we now connect to our database without, come back. Oopsie. If we now, what's the best place to do this? Let's just pick one, pick a for each, and we remove the, we can do that at the project level. We'll make it connect with shared memory. We'll see the significant improvement there. Connections, 1, 2, 3, 4. Take that off. I'm not sure you can read that, that's pretty small. Next, finish, apply and close. And if we now run the for each, which is our bottom one over here, I'm just going to copy and paste it into, that's our for each there. Don't save, or save, okay. Right, we can see the massive difference in timing from shared memory, right? We've gone from 1400 to 200 milliseconds for the total. Again, the indexes have the same impact. If we look at our record reads and table reads, we would expect to see those to be the same, but our network traffic, because we're not going over a network, is now obviously reduced or non-existent. Does that run? There we go, it ran again. Right, so we've read, same number of indexes, the reads are the same, we just get it faster because we're not having to move it across or because it's in shared memory. I counted that faster than I thought. So yeah, as I said, I think the, you can read mostly that. Again, in the newer versions, 12.4 and beyond, if you're counting database records, aggregate is definitely the way to go. Right now, you can do the for eaches on it. And then between the others, the mileage is more or less the same. You're looking at roughly the same time. Pre-select, as I said, I think pre-select is my feeling is the next fastest. But in testing, I'm not sure if we did an identical test and try to strip out all the variables, right, this is my laptop I'm presenting, and it's a little bit faster or slower, but pre-select is probably the next best. If you must use a slow one, you can use the accumulate function. If you want to impress your users by making it faster in the next release, put the accumulate in and then change it for the aggregate. There's a question.
Yeah, well, we'll be going to the questions, but we have a question from the online. Did you do something similar with temp tables as well?
Did I do the test with the temp tables was the question. The answer is no. At least partly because things like the aggregate doesn't work with it. With the temp tables, we have the option of, we could actually do that now. We've got 10 minutes. So if there are not other questions, we can do that with temp tables. Obviously, it would be the for each, the pre-select, and they accumulate, but I don't think we can do that. But the aggregate and the SQL selects are going to be on the database tables only. But since I'm feeling bold and I've got demos working,
Sorry.
For the new aggregate, can you have a dynamic kind of query as well, or is it just static?
So today, the aggregate is just static. It's just on static tables. There's no dynamic variant on it. I do not know if there are plans to do a dynamic variant on it. I think it would be really nice if there was a dynamic variant on it, and I will suggest for that going to either ideas or asking on the CVP. Those are the through which to ask those kinds of questions. But I do not believe there are plans for a dynamic version of it. So we can do, well, this will run nice and slow. All right, so let's do this. Let's just mess with progress a bit. We say define temp table customer for custom like customer, right? No undo. Null undo. No undo. I'll get there. Right, like customer, and then this is going to Always, right? Always that one. Please put create customer, buffer copy, customer. Right, that should work. Is there anything glaringly wrong there? I think that'll do the trick. So that's going to take a couple of seconds. Well, let's see how long that takes to run. Let's just do that. There's 200,000 records. You want to guess how long that's going to take? Probably going to take 2 seconds, 3 seconds. We'll see. All right. And then, so what we're going to do here, what we've done here is we've created the ABL is nice like that. Some might say nice, some might say not nice. You can create temp tables. That's what we've done up top here. A temp table named customer that is the schema of the customer database table. And because we've now called it that, we've qualified when we want to create the database records, we're going to read those, create temp table records from those, and then our queries down here should, in theory at least, read the temp table. Do we believe that's going to happen? Yes. All right, so actually we can check because we will reset our little counters over here, and so we should only see 201,000 reads. We shouldn't see the million reads, right? Because they're all going to get read out of the temp tables. So, run as donk. 1 Mississippi 2. 6 seconds, right? To do the copy, and now the rest can run. So that's local temp table counts, right? And again, we've just run the 201,000 records. So that's that one, and then we will take all of that and then look at them for the pre-selects. Cut and paste code is the best code, isn't it? It's the most robust code out there. Compile U, and we are going to run the pre-select text again. Run as bump. Save, yes. 1 Mississippi 2. 5 Mississippi 6. And a bit. All right, and off she goes. Yeah, so the kind of results still roughly hold. Empty fields is slower here, faster there. So they're, I'd say, roughly equivalent, obviously significantly faster than what we had with it. Where was our accumulate that had the database in it? One of them had the database stuff in it. Aggregate had, compared that to the network. We can check that again. We can run the database ones again and see where we go. But yeah, so with temp tables, your options are limited to the for eaches, and to Carl's point, you can use dynamic programming with them as well.
Yes, I have a question. If you're using a data set and the fail command, but you also set a batch size, how would you return to the caller that I'm returning you 100 records as you asked for, but it's a table with 12 million records?
So the question is, you have a data set, you have an option on a data set to set a batch size, so you can say, and where to start and finish, right? So it can move down in batches of 50 or 100 or 500 records. If you have 12 million records in your table, how do you know how many records are in the temp table? Well,
in a database table.
Oh, in the database.
Because you only read like the 100.
Then you use one of these techniques. I mean, then in 12.4 and up, you use aggregate, because aggregate, I think, on 12 million records will be quite a bit faster than the for each will be. For that database. Sorry, I thought you meant on the temp tables, but in the database, the techniques will be the same, right? You would have to read out of the database. Again, somewhat tricky in that case, right? We're assuming a single table. Mostly the stuff that goes into a data set is going to be a join between multiple tables, and so the aggregate today doesn't work with multiple tables in it. So you're kind of limited by that.
So usually there is a main table in your...
Yes, usually there's a main table.
Gus?
So, two things about the pre-select. One is if you're doing that across a network connection, the records don't get sent across. It only sends the row IDs for the result set. So as long as you don't touch any of the records after the pre-select has got collected the result set, then only the row IDs get sent across. And the other thing is that you should do a forward-only query for this kind of thing, because that will optimize how the result set is stored on the client side.
Okay, thank you. So again, this is somewhat contrived. I mean, I think typically you would both count the records and then do something with them, you know, instead of just a pure count. But there are cases where you want to do a pure count, right? We can try that if I can remember where to put forward only, or we just look in the help.
So I have one other comment, which is you can do a database analysis report and it'll tell you how many records there are in all the tables.
Yes.
Yes.
And you run that every night.
Does anybody remember where to put the forward only? Is it on the query definition, or is it on the, it's on the query definition, right? Nope. Somewhere here. Nope. When all else fails, just cut and paste, right? Where are you? Where did you go? Forward only. Query object handle. But it's defined query, right? Or?
Does it go before the no log?
I don't see it there. For field list, buffer name, scrolling. Is it the scrolling that does it? That turns it into a forward only? Oh yeah, I'll do that. That makes sense. Come on. Yoo-hoo. All right, so we're going to say, before we open it, we are going to say query customer, forward only equals yes. Yeah, it compiles. I like it when things compiles. It means I can ship them. In the, we take our little temp table nonsense away. How that. It's the beauty of the ABL. You can just like mix and match stuff, and it's just like. Well, I think it's the beauty of. Pardon? When it does. When it does, which is mostly. All right, let's run. Pardon? I do want it on both queries. You're right. Thanks, Chris. That one. And we go reset our screen over here. And before we do that, we have to go and reset our database connections because we want to have it across the network. Otherwise, it doesn't make the blindest bit of difference. So we do U, and we say 42042. It's our network. Finish. Apply and close. All right. And then, why don't we take our pre-select numbers? Oh, so they were roughly 1100 milliseconds last time we did this, for each anyway. So we'll compile you, and we'll run you. Let's see what you do. 1 Mississippi, 2 Mississippi, 3 Mississippi. Yeah, so 10%-ish on that. The fields is not much faster. It's about the same as it was. I mean, in this highly scientific sampling, it's about the same. We look at our record reads. We've got index, record, index there. We've pretty much got 3 times the index and the record reads on those. So that helped a bit. Any other questions, comments, techniques, tips, other ways you found of making things go faster when counting? Gus?
Yeah, so if you are going across the network, you should set the network message buffer size because it defaults to 1K.
Yes.
So set it to 16K.
Yes. So there are, just to elaborate on that, there are a number of, I think the analogy I saw by somebody a couple of years ago was, you think of the traffic between the client and the server as trains, and so you can alter how big the carts are, how much cargo you can put on each train, and how big the trains are, how big the tunnels are. So there's a couple of network settings that affect how much data is sent backwards and forwards, how many records are stuffed into the packets across the wire, all of those sort of things. Obviously here this is just using whatever the defaults are, but they can have a significant impact on that traffic. Any other questions or comments? Yes?
Yeah, just a second.
One little point about performance testing is, one little point about performance testing, there's probably two things you need to also watch out for. One is caching of records. Okay, first time through, if you've had a database that's completely cold,
yes.
Your first run has the overhead of getting everything into memory, and then, so if you're doing some kind of A/B type test, well, your A is always going to be struggling because the thing you run next is piggybacking on that caching. The other thing is, as well, depending on what else is going on your network, that can also have a fairly massive effect on what's going on if you've got anything that's running over any kind of period of time.
Yes, definitely. I mean, as I said, in this case, this is, the database has been running for a little while. It's got, whatever its -big B is, the default. I've run these queries a number of times on that, so they'll be full of customer records. We're just on one table, so that cache will be full of customers, right? The same set of customers. I don't know if it's big enough to hold the whole table, so there's probably some buffering in and out of that as well. So we are measuring some of that, I think. And I mean, you could see the run speeds when we did them a couple of times vary by, it varied by probably 10% run to run. So there's definitely that. This is not a lab condition test. But so I totally agree with what you're saying. You need to have constant.
The reason I'm saying this, actually, I'm probably just going to bore everybody with this little war story, but we were trying to speed up one of our processes that's called on an app server, and it was actually somebody from a different team that was making the calls, and the original plan was at lunchtime we were going to deploy the new code, and so they were going to do a load of testing in the morning and get some numbers, and they were going to do a load of testing in the afternoon and get some numbers of the new code. Anyway, we just clean forgot all about this, and so we just kind of didn't deploy the new code. Anyway, she got really excited. She came through. Look, John, look at these numbers here. Look at, and it was a Dynatrace graph. Look, wow, the stuff in the new code is twice the speed of the old code. And I'm just thinking, Christ, we forgot to deploy it. It's the same code is now running twice as fast as and it'd been running for an hour, double the speed of the original thing. So, and we never found out what it was. I think it's probably network.
Yes. Yeah. I mean, that always with the performance testing is the hardest thing to, like, if you're trying to test something realistic, real life, and you have a network in the middle, I don't know if it's even possible to make that consistent between runs. I mean, yeah, definitely. No more questions? Any comments? If not, then I'll say thank you very much for your time, and I'll enjoy your lunch. And see you later.